How is the material? Are you having any questions, any concerns?
Not too bad. I've got to study.
For the test, you mean?
Yeah, for the test.
I'm trying to load it up so I can show you a little bit about it. What is your studies? What are you doing? What is your plan?
So I've made most of my flashcards. I
Okay.
gotta finish making all my like from last week's terms.
Okay.
And um
And is that helpful making those? Like the process of making those? You find that helpful?
yeah, so
Mhm.
far
Good,
I
good.
like searching up the images because there's so many different like views of it, and so
Yeah, that's
that's
the
how.
thing I find very helpful actually too. Yeah, yeah. And then do you have the term list so not that's the terms you have are finite. There's not more terms than that. Do you have that?
Yes, the term one list, right?
Yes, yes. I
Okay.
want to make sure that we at least touch on this until we're starting about it. I make a video that way because sometimes people think they have to use all the terms that are there's way too many terms. So we want to make sure it's not too many terms.
Yeah, at
Um,
first I thought it was all the terms in the book, like the
no,
over
no,
the
no.
book. And I was like, oh my goodness.
No, no. Do you have that term list, or do you want me to show you?
No, I have it. I've been
Okay.
using it for the labeling and coloring.
Okay, great. Yeah, exactly. These are all just the terms combined that are in the exercises. Um, and then the other thing is, has any of you guys watched the drill that I sent you last week? I think at some point. Like
I have not.
so, on the text today, I sent you two drills that I did last semester in the classroom. And so I'm trying to I go like with the models and I point to different structures that I choose that are sort of some that I usually like to put on the test and stuff. And so if you watch those before you take the test, that might potentially be an interesting work through, or at least one of those. Maybe the second one has all the terms. The first one has the bone terms. So if you go back in the group text I sent you to announce the Zoom, maybe it's like 20 minutes. You just do it passively. You sit there and watch it, and I do the drill, like do 10 terms, and then I talk about them and point them out, and so maybe that will help more to remember it easier as well. And remember, it's an open book test. You remember that too, right?
Oh, I was actually gonna ask that because I didn't know if the test, like the big test, was open book or if it was
Yes.
just little ones.
No, all my tests are open book.
Okay.
And so, because I'm mostly interested in you guys organizing the material and learning about what it does and so forth, and the terminology, yeah, is important because we talk to each other about this, and so we're establishing a vocabulary. But I just think they stick more in the brain when we do stuff with them, and so even in a test, I have it open book,
Okay.
and I think it's a 3 hour. I give you a 3 hour window to do it, so it's a long time. But yeah, use that lab thing if you and also on the lab review or on the test review there's videos there that I just talk through all the terms. That's also a good way to potentially be able to absorb the information again, or go through it again, and just have different ways to be have it be presented to your brain in different formats makes you also remember it easier. And so that's sort of another thing that I recommend. What else? There was something else I was thinking about with that. Oh yeah, you in the Padlet this morning I read someone was concerned because of remembering all the origin, insertion, and action on the muscles. And the test, you only have to identify the muscle. You do not have to know origin, insertion, and action. That is for the test itself. I'm not asking you for that. That's why I make you do it in the homework. That way we process the material by, you know, learning those, and then at the end for the test, I want you to just be able to recognize the structure. Is that
Okay.
okay too? I hope that helps a little bit. Were you guys aware of that, or was that generally not quite clear to you guys yet?
It
Anybody?
was understood.
Oh, okay, good. So I mentioned it a few times. That's good. I'm gonna make sure if it's too many people, I gotta start talking about it more. Um, and then what else was there? Oh, and then in the test, unfortunately, my internet must be goofy. I can't upload the test to show you. But in the test, you're gonna have pictures of structures with labels on them, like 1, 2, 3, 4, 5, up to 54 at the end. And um, and so then you have your term list with you. You have all the information you need to learn, understand what structure is what. And then I also show a video of the structure that you need to identify, and I have everything as an external link as well, the video. So in case you're goofy on the technology is a little goofy and you need to go to a different platform, then you have that ability with, also getting the external link as well. And I give you 3 hours. So that gives you plenty of time for most people or most of you guys to do it. If you have technical difficulties, and don't stress out. It's part of the process. That's why I give you a long time. I know it's not like ideal, but sometimes technology is a little slow with these things still. And the best browser that I have found that works on this stuff is not Safari. If you work on a Mac, it's more like a Google Chrome or a Firefox type thing. Although I haven't tried Firefox in quite a while. And then or a mobile device. Actually, the mobile devices usually work really really well too these days. And so if you have, make sure, uh, and if you have problems, you just text me, and I'll figure out how to help you, or we give you a different another attempt or something like that. So don't try to not freak out when it comes to these kind of things. I mean, I don't need you to freak out anyway. I'm trying to make it so it's not a freak out experience. My hope is that an exam, is sort of a last go about through the material and get you a then we can close out that section and go to the next section, and your brain kind of put a check mark on it too as well. In the test, I ask you specifically for three things. I ask you for muscles. That's easy. I mean, easy. Just when it's red, and I ask for muscle, you give me the name of a muscle from that list. And then on the bony side, I ask you for the bones themselves, but I also ask you for landmarks on the bones. And so, if, for example, that when I say, "What's this bone?" you're gonna say it's the frontal bone, and then I'll say, oh, sorry, "What's this landmark on this bone?" and you're gonna say the glabella. And so that's the differential there. So make sure you pay attention to that. And I think that's about it in terms of the test. What do you guys have? Any questions that I didn't address right?
Yeah, I have a question.
Yes.
You said these are fill in the blank.
Yes.
So with like misspelling, is that like a half a point off?
Oh, yeah. Good point. No. Well, unless it spells another word, or it doesn't spell anything, I give you the full credit. So but what happens often in this test is I can't put some common misspells I can put behind, and they don't catch it as bad as a mistake. But a lot of the misspell, obviously, they just catch it as a mistake. And then I have to go behind it and hand grade everything. So pretty much everybody across the board, unless not everybody, most everybody across the board gets more points added to their test. But of course, the better spelling you do, the more, the less work it is for me, because that's the hard part, to really go through everything. And so try to be as exact in the spelling as you can by copying it over. Maybe I should take some points off. Oh, that would be interesting. But not this semester. You're still in luck, so don't punish whoever said. No, I will not do that. No, you just do the best you can, and I do the best I can. But I ain't gonna give you a bad grade because you can't spell. I mean, I can't spell right. Just take your time and make it as positive an experience as possible. All right. Any other question? But thank you. That's good. That's important, because don't freak out if your score seems low. Text me if you freak out. Text me, and if I have an ability, I'll grade it right then. But I'll definitely try to be on grading with these tests coming in as you guys do them. Also, the less you procrastinate taking them, the more you probably get a chance I grade it right away, because the early, I don't get as many early on. I get everybody coming at the last minute sometimes, with this kind of stuff. And if you see, I give you, well, actually, how long do we have this test open? Oh God, my computer is so slow.
Are we allowed to retake it in
No.
the time that it's open?
No, the tests you can only take once.
Okay.
Yeah,
for sure.
thank you for asking that too, because that is the main difference with the test versus the questionnaire kind of things,
Okay.
or the homework. There's, like, when you look at teaching styles or teaching, there's the type of teaching that, I forgot the word for it, but that sort of works the material and process the material. And then there's the teaching, the testing type or assignment type where you want to be a bit more testing the knowledge level, building up to that. And so that's what we've been doing. And now we finish up with this test that, we can't retake that one, unfortunately. Unless, you got a very good reason, like my computer crashed and blah, 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 and I can see that, then we can totally talk about it. So don't, wait. How long do I give you guys for this thing? I got to look that up real quick. I think we got to Sunday, right? From tomorrow morning to next Sunday. Exam. Yeah, the 24th. So you have till the 24th next week. And then after that, we have a break. There's a spring break coming up. I didn't space out the spring break. But what I did space out is April 1st is actually a holiday at Merritt. So we don't have lab April 1st. And then I have to get to my home for a couple of weeks, and I planned that from after the lab, so I can't do Wednesday that week because I'm actually in an airplane going away. That was a little miscalculation on my part. So we're gonna integrate the heart in the lab either the 29th or do one in addition to that. And I will announce that and we'll talk about that. But we will have lab tonight, and we will finish up the lower extremities in the lab. It's been a lot of fun. People have been enjoying it, apparently, because I'm reading it on Padlet. And we have fun in the classroom too, going to the cadaver labs and doing it physically and getting the models. So if you can make it, try to show up if you can, if you're interested. And if you can't, and somebody felt a little bad about it that you can't, we can talk about, if you guys want to have a session where we go in and do a cadaver exposure, where I can get you guys to show you some structures that's a different time, or a Wednesday, or a different week, or a different day during the week. So if you guys have interest in that and you can come to the lab, I think we should maybe do that if there's enough interest, because it could be a good addition, and if you're interested in that, because being exposed to a real stuff, the way it really looks and feels on the inside of the body, is a very, very valuable experience. And we do have that ability to do that at our school, and it's very unique for a community college. So a lot of places, including nursing schools and stuff, they don't have those things anymore. So I want to just throw that out there. Text me privately if you're interested in that. If you're not able to come, that thought just came up this morning when I read that Padlet. Anywho, that's that for that. Any more questions to the test or to the lab tonight? If not, then we can go to this week's material, because I do have to start with the heart. And this week we're gonna start a new section again. We're gonna now start the third part. So you have a break next week. So in terms of organizing yourself, let me take this out. Do finish. I would, no, you do it the way you want to do it. But if it's too overwhelming to start with the heart before you finish the muscles, you have kind of 2 weeks to do that thing in kind of that, because we have a break. So make sure you take that into consideration. Even if I do keep the due date next Sunday, because I don't want anybody then just table it a whole week and think that's the due date, and then we don't keep working, because I also want to have some people work ahead, and I open all the modules now, and so that's also what some people probably do during the spring break. So there is that flexibility, and again, whenever there is a late penalty, that is sort of to keep us going in line. That late penalty never goes below a 90, never below an A. Most of my our work is get full credit or not full credit. So if you're doing it, you get the full credit. So in that respect, it's not really that tangible. And then at the end of the semester, if it is tangible and give you a problem in terms of the grade cutoff, then we fix it at that point. So please just keep that in mind. I'm not able to fix it every along the way for everybody individually. That's just too much finesse going back and forth the whole time, and I go crazy about that. Just be patient with that, but know that that's how I deal with that. And ever since I started that, most of the classes sort of doing the work at the same time, which is definitely helpful after all. Because in this time now, we are also working on now past the muscles, past the bones. Now we go to the visceral organs. We're going to start with the heart. We're going to blood vessels, blood itself. Then we do some immune system. We do the endocrine system. And then we go to the brain and the neurology. That's kind of cool. Take us a little while there. And then we finish up at the end with what are we going to have? Nutrition. We have the immune system, respiratory system, digestive system. We do some nutrition on it, and then we do a kidney, the renal system, and then afterwards we finish up with the reproductive and embryology at the end. It's a lot of stuff, a lot of different chapters. I don't have a test until the end because I don't generally. Well, online we could do that, but I also have multiple projects that we do, and we have a really good test review at the end of the semester. So I want you to make sure you start going to the test review. Let me see if I can pull that sucker up, because I'm really not understanding why it's just not letting me do that. So let me restart this program. Oh, there we go. I think I might be able to get the modules going, and then I could show you that. Because I think if you start with the test review, well, it's loading. It's going to take a moment, I guess. If you start with the last part, the last module is the test. So go into the test review there, and the test review that I've written up there is very detailed. It's like 5 pages, but it spells everything out that I need you to know for that test. The part 1, and that test has 2 parts to it. Part 1 is like test 1, multiple choice and so forth. That's where the test review comes in very handy. And then part 2 is going to be similar to the test that we are taking now. The terms are just less terms but we still have anatomy terms for the structures like the heart. We have some blood vessel stuff, and actually we don't have blood vessels, but we have blood cell types, and then we have brain structures. We have eyeballs and special senses and lungs and kidneys and things like that we have anatomy structures too, but they're just not as vast in that respect as the muscle and bone department is. Look, I can actually load it up now here somewhere. So if I go in there, see, now I put everything up. This is where we are now. I open all the modules that we need, and here on the test 3 you have this review, and I want you to start. Once you start with this material, start right with this test review in here. Let me see if I hope it's loading up. We'll see if this one is loading. Yeah, look at that. So this one's loading up. So there's a lot of terminology here, but I know a lot of bullet points, but these are all the bullet points I need you to know for the test. For test 3, in terms of the written type material that we usually discuss in most of the chapters. We do have then this test term list that we start using as we get through the coloring and labeling. That's still the same process. the coloring and labeling, and then the term list just looks like that. And so you basically start within the chapters with the different terms of the heart and then the blood, and move your way through it, but it's all consolidated on this term list in the test review. So that's for that part. And then let me start. And if you have any questions, just interrupt me, please, okay? Because as we get into the heart, when we look, let me find where I can manipulate that stuff around. If we look into the heart, we're gonna start learning about the heart having, it's a double pump, and it pumps blood through the body, then through blood vessels. So we learn where it is. It's between the lungs and the chest, and then we learn the different parts of the heart itself, like in here the different layers of the outside, the walls of the heart, and then the inside structures. It's a hollow organ that fills with blood and then squeezes, and the blood pumps through the body that way. And it's an interesting structure because it's two pumps in one, and one pumps the blood from the heart to the lungs to get oxygen, and then the other pumps the blood from the heart to the whole body and brings the oxygen and everything else that it brings to the body cells, and then the body cells can utilize the oxygen they use for making energy, and the other stuff, the nutrients and all that they use also to make energy, of course, to harvest. And then the blood is a very good medium to carry things that are soluble in liquid around the body. That is nutrients a lot of the times, but it's also waste products. And then some waste products we can bind to physical structures like the oxygen or the carbon dioxide. And as that blood passes through the lungs, we can breathe out gas waste like carbon dioxide, or breathe in things that we need for the body, such as that we can utilize, such as the oxygen that we harvest from the air. So that's kind of an interesting, it's a very interesting organ. And then we talk a little bit about the blood vessels in here too, what they're called as they pump the blood away from the heart. They're called arteries. They're usually depicted red, although the red stands for the coloring in the vessels in the anatomy book stands for fact, not if it's an artery, but if it has oxygen in it or not, because the oxygenated blood has a little brighter hue to it than the deoxygenated blood. Looks a little bluisher, and that's why blue and red. But the term artery comes from the fact that the blood vessel that goes away from the heart has to be withstanding a lot of forces that are pumping forces that are really strong, hydrostatic forces, they call them. And then on the other end of the spectrum, well, you have the blood be pumped to the body, and then as it gets into the parts where it needs to deliver the oxygen, the vessels get smaller and smaller and smaller until you get these vessels. They're called capillaries that everything seeps into the tissues from those vessels. So they're very leaky vessels then. And then on the other end of the tissue, where the perfusion happens, we need to pick up most things again. We need to pick up most liquids, and we need to pick up a lot of the waste products. We bring these into the veins. They're called veins then at that point, and they're looking different because they don't have to withstand those forces, but they have to be guidances. They have to guide the blood back to the heart to then be pumped to the lungs to have these exchanges happening in the lungs. And so that's sort of how the whole system works around the body, and you're going to learn more about that, of course, during the videos. So look here, the chambers. It's interesting when you look at this. You have a right heart and a left heart, and in each side you have a forechamber where the blood sort of comes in from the body, and then you have it sixers in down into a main chamber. They call that the ventricle. And then from the main chamber, when this part contracts, it squeezes the inside, and the blood that's in here has to go somewhere, and it can't go back because you have actually these valves, they call these doors that close, because when this heart contracts, we learn from muscle contraction, it shrinks, right? It shortens. When this shortens, this gets smaller, this gets squeezed, so the inside gets squeezed out. And these strings here come closer together, and they close the hole between the forechamber and the main chamber. That's how detailed this stuff is. You think about that, it's crazy. And then as this physically gets smaller and these doors close, then the blood has to go somewhere. It can't go back into the forechamber. It has to go up here. And there's another set of valves that open up. They open upward. And so as the blood gets pushed out, it have to open those valves. And these are here for when the heart stops contracting and relaxes. All the blood that's still in here doesn't just fall right back in and we have to pump it over and over and over again. So that's why we have those valves. But the other purpose for those valves are when we contract the heart on the inside, it takes a little bit of force to push those doors open. And that little force gives it extra oomph, extra push, that the blood gets pushed further into the body with more force. And so it's an interesting thing to have these things. So that's just a little, and you're gonna learn about these names. It's does that make sense, you guys?
Yeah.
Okay, let me know if it's too fast, too weird, too any. I just like to give you a little overview, and then you can watch the videos and get the details. And then we talk about these names. This is known as look at the name. Inter means in between. Ventricular, these big chambers are called the ventricles. But the other reason why I put this picture up, because look at these nice strings, how that looks just pretty. I mean, I think it's pretty, of course. And we're gonna see in the heart when we in the lab, we dissect a sheep heart. It's not quite as big as a human heart, but it all has the structures and it looks like it on the inside. And then these are the valves. We talk about the valves. I just mentioned those before. Blah blah. You're gonna go through it, and then we already talked about part of the heart pumps the blood to the lungs, and then we call that a circuit. We call it the pulmonary circuit. Anything with the name pulmonary, you think of lungs, and then the other one is the systemic circuit because it pumps the blood to all of the whole body. System means the whole body, and then you got all these different names. We talk about them. That's why I like to use color. That way, it's easier to find them, and so that's that. And then you have one. This is just a picture in your booklet that shows everything. This is a good picture to study or use for the lab thing. If you're just watching the video, just take a screenshot. That's good too, or something. And then, oh wait, let me put it back in case. Well, you could just stop the video. There we go. Most of it is on it. If I do this, is this better? Uh-oh. Can you see the screen better? Anybody? Hello, is anybody still here?
Yes, it's good.
Okay, good. Okay, and then we also end up having the heart is a muscle, and so it needs food from its own self for its own muscle as well. But it can't get the energy and the nutrients from the blood that's inside of the chamber. It has to get it from vessels like every other organ, and so it has its own blood supply that comes right out of the lower part of this is the aorta, the big vessel that comes out of the left side that then carries the blood to the whole body is the aorta. It goes up like that and it arches and goes down into the chest and then through the abdomen, and at the end it splits and goes into the legs. So these stumps up here are then the vessels that go up into the head and into the arms. We're going to give those things names. But in the back here, this is the back of the heart, we see these coronary vessels come up and out. And coronary means it feeds the heart itself. And so these vessels are the ones that feed the heart itself, the heart muscle. So they're very important. They're very important when you have a coronary artery disease. That's the coronaries right here. That's the heart attack issue. If we get those be too blocked and the blood doesn't get through and can't pass, or also sometimes if the heart muscle is too big, it's just too much for the whole thing to manage. And then we get into some of the physiology. How does the heart work? The heart is an interesting organ because if you think about it, it has all these different muscle cells in a very uniform structure. That if you actually drain all the red stuff out, all the muscle cells, you still have a heart that's white. And so the fascia is really really strong in the heart. That gives it that skeleton. It's almost like it's not a bony skeleton. It's almost like a collagen type skeleton thing that gives you that firmity. And then inside there are the heart muscles, and they're all little small tiny cells. But the heart contracts in one unit. Have you ever thought about that? I mean, it's like the heart goes dum dum dum, and what actually happens is the heart itself has a brain that has a little bit of a brain. It's called this node, but it's not a brain. It's a collection of nerve cells. But what they do is every they leak ions, and every so often they let a nerve impulse go, and that's about 100 times per minute. No, look at that, 60 70 times a minute. They let an impulse go because they leak some substances, and the leak of the substances changes the threshold of certain ions on the inside, and then they lets an impulse go, and it goes through all of the heart muscle, that impulse at once, and that whole muscle as a unit. All those cells contract as one unit, as one cell. And so one thing that that we learn in epithelial tissue was the connections between the cells, and we have the gap connections in the heart. So the gap connections are holes that let the ions flush through it, and they let the muscle contract as a unit. And so that's called a syncytial unit. And then you have a reinforcing place here where that impulse gets reinforced and then travels through the entire big part, the big chamber, and makes that big chamber contract as one unit. And so that's kind of an interesting sort of structure. And also the fact that we have this first place where the impulse starts, and then spreads over the forechamber, makes the forechamber contract a fraction before the main chamber, and so it squeezes all the blood out of it into the main chamber before then the main chamber contracts and squeezes all the blood out into these great vessels, the aorta, and then the other one is the pulmonary trunk that goes to the lungs. And then they have all names. You're gonna go through the names when you go through the video. But that's kind of cool. Does that sort of make sense?
Yeah.
Good. And so there's just all this talking. Look, I should have gone through all these pictures. You have all these pictures in the video. And then that's where the electrocardiogram comes from, the EKG, and we'll learn what that is. We see the word excitation here. So this little bump here is when that spread goes through the atria, the forechamber, and makes that forechamber contract a little. And then this big spike here is when that thing here spreads through this main chamber and squeezes this main chamber and lets everything, all the blood go out. And so that's a big, and this is the electricity that gets measured. That's a big electrical force, right? Sorry, I asked you for that. There we go. Okay, let me go back to that. Sorry about that, real quick. And then the last bump here, that T wave, is when the big chamber, the ventricles, are getting excited. Then they relax, because during the relaxation phase, the nerve has to, the muscle as well has to recover, and nerve impulses is fired by ions going across the cell membrane, and ions are charged molecules. We learned that a little bit in the chemistry chapter, and we're going to get more into that in neurology. And you have a chemical, scramble going on when you have these crossing the cell membrane. So you have to carry them from one side of the cell membrane to the other side. So you have to unscramble the ion, so to speak, and that's done in a process we call that depolarization in here, because when you look at the electricity portion, you look at the charge. That's why ions are charged molecules, and the charge gets shuffled around, because the change in charge itself is the nerve impulse. So that might be a little complicated, but we're going to talk a lot more about that in the neurology. And I am happy to go deeper in it if you're interested. Just Let's do it after we go through the chapter, and then next week, or actually next week is a off week. The week after that, on the 1st, then we can talk more about it if you'd like. And if you want before, just shoot me a text. We'll make a session. And then we have some terminology. We have to talk about when the heart contracts, where the heart relaxes, and that's where the terms systole and diastole come in. And you probably know those terms from blood pressure, because the systolic blood pressure is the higher number and the diastolic is the lower number. And that makes sense, because when you measure blood pressure, you measure the force pushed against the walls of the blood vessel by that force of what comes out of the heart, that push. And so when the heart contracts, that force wave, that pressure wave is stronger than when the heart is relaxed, and that's when the pushing forward of the blood drops down. And so that's sort of in a quick short how the blood pressure taking stuff works. Because what you then do is a blood pressure cuff, you put it around, the arm or the wrist or so, and you compress it. And then you measure how much is that pressure wave against the vessel, how forceful is that, and that's in part why the arm is more, the wrist is not that accurate, or at least the home ones. I have one, I never use it. It didn't seem doing too good. And then we have heart sounds. You probably had that happen in your life, and you go to the doctor and they put that stethoscope on you and go like hearing your thing. They hear long sounds as well if you're wheezing or so, but they also hear for lubbed up, lubbed up, lubbed up. And lub and the sounds are closure of these doors, closure of these valves. It's sort of like, somebody slams the door real hard and then you can hear it. Although, in the heart, thank God it's not that loud. But the lub indicates when we squeeze all of the blood out of the 4 chambers into the main chamber and then start contracting that main chamber. When those strings come closer and the valves cover that entrance, that's the lub sound. And it happens on both sides of the heart. Even I explained it on one side. So yeah, this is a double pump, right? The blood here is blue. So the blue indicates no oxygen. When it has no oxygen, it's got to go to the lungs to get refilled with oxygen. So that's here. And then these are the pulmonary trunk here. And then a second set of the valves is the dub sound. And that's when the blood does get squeezed out. And then the heart relaxes afterwards. So and then these valves, they close because the blood that's still stuck in them, that doesn't get makes it over the hump, falls back down, and that closes, and that coming together of these little valve thing makes that noise, and that's then the dub sound. So it's a little different. The lub dub, it's a little different kind of sound, more high pitched a little bit. And so that's the reason for those. And we go into detail in the video more, and also you have a diagram here in the book where you can actually learn how to place the stethoscope for the different types of valves that you really want to hear. And this is the places where it echoes, the sound echoes best off for the chest wall to hear it. So, I mean, this stuff, medicine's done some pretty sophisticated kind of level of stuff, especially when it comes to cardiology. And listening is a huge, huge piece besides the electricity of how the heart works. There is some of these stethoscopes are like amplified, so it's like, incredible technology at this point, how detailed of a sound differential it can pick up. Because one of the things you want to pick up is like, are these valves efficient or not? And the valve might not be efficient because you might have what they call it a murmur. You might have a valve that doesn't close all the way, and it doesn't open all the way. That would be insufficiency. Or you might have a valve that doesn't close all the way. Oh no, it's the other way. Sorry, open all the way. Stenosis. That's always something gets too narrow. We call it stenosis when that happens. We call that term we also use when the spinal cord gets squeezed by the vertebra a little bit. That's spinal stenosis. That's where they do low back surgery in elder people a lot of times. But insufficiency is when it doesn't quite close. And so if the valve is not quite closing and the heart contracts, some of the blood will go back to the 4 chamber. So that becomes a problem. Potentially, it doesn't have to be. But that stuff we can pick up by listening. A lot of these stethoscopes are very, very sensitive to the listening. And then this is just talks about all of these steps of all the stuff that I've been outlining. One of the things we have to do in anatomy and physiology, we have to categorize things, or in science in general, we have to categorize things to be able to talk about them. And that's what we're doing here. And then lastly, I think one term that I want you to learn is cardiac output. And that's the amount of blood that can be pumped by the heart in 1 minute. And the coolest part about that is, look at this. Normal sitting here, me talking, you listening, hopefully not sleeping. Sleeping is lower. The heart pumps about 70 beats per minute on average at rest, and about 70 milliliters per beat. What's a milliliter? Oh gosh, a milliliter is hundreds of a liter. So, no, it's a thousandth of a liter. So 70 milliliter is, it's about a handful. Let's say it's about a handful of blood. It's not that much blood. A little bit less, a palmful. But the cool thing is, look at this. The heart can, from 70 or lower, it can go all the way to 180 per minute for brief periods. So if you have to go sprint and run away from a lion in an emergency situation, your heart, don't do it if you're older or not healthy. But if you're training healthy, it can go up and go to 180 times per minute. And the volume, because the heart can stretch also, and when it pumps more and faster, it will stretch more. It can double its volume to 140 milliliters. So in essence, you can go from about 5 liters, which is about, let's say, gallon and a half ish, to about 25 liters per minute. You can 5 times push that blood through the body if you have to for brief periods. So that's why I think that's really kind of cool. Just to illuminate that. But the term is used, the cardiac output, to measure that, and it's heart rate, how many per minute, and then stroke volume, how many milliliters per beat. And this is science, so everything goes in milliliters and liters and centiliters and stuff. If you need help with understanding the liter world kind of decimal system, just reach out. I can hopefully help you a little bit with that if that's a problem. Otherwise, we're not going to worry about it if I don't hear from you about it. Good. Well, look at that. That's all that I have to say about this stuff. All right. And let's see what we're doing this week. I think this week is. Oh, shoot. Did I not be able to? Oh, here it is. Let's make this big again. And then let me go there and we'll see what we have. So I open all the volumes here, except this is not for us. This is testing. I'm not in the student view, so you see all the stuff I have. But we also do the blood vessels. Shoot, I didn't talk about the blood vessels much. Well, the blood vessels, I want you mainly to enter lymphatics. We briefly talked about the arteries and the veins already, and the capillaries. You will just go deeper in the structure of the vessel walls in here, which they're all coming the same walls. There's 3 walls. There's an inside layer, and then there's a muscular layer, and then there's an outside layer, and you'll talk about that briefly. And then I will go through some of the vessels themselves, but I do not test on their terminology because when I entered the classroom, the models were just really not that easy to identify what's what, and I'm not going to do a guessing game in a test. But I do talk about it in here. But in general, what's cool about arteries and veins is most of them are named by where they run or where they go to. So if an artery goes by your arm, we already had all these muscles now. It's probably called the brachial artery. And if it goes by the forearm on the side to the thumb where the radius is, it's probably going to be called the radial artery. And so you got all these names that you've been learning that now you can put together, and arteries is a great place. And that's why I'm kind of, lecture on it. We do questions on it, but then from a terminology, anatomy term quiz test at the end, you don't worry about that. I'm not testing you on that stuff. And then the other thing that goes on in this module this week is the lymphatics. And the lymphatic is interesting. If you think about the blood, a lot of it squeezes out when it's blood. When the arteries bring the blood to the tissues and it gets all into the muscle and it's all liquid in there. And how are we going to get all that liquid back into the veins? And some of that gets pulled back in with that what we learn is osmotic pressure, because some of the larger elements of the proteins of the blood itself stay behind and don't get squeezed out through the capillaries because they're too big. They can't go through, physically can't go through. And then they become like the salt on the tomato. They attract the liquid and it squeezes it, brings it back into the veins or the capillaries on the venous side of the capillary bed. They call that area where the tissue exchanges, the fluid exchanges. But it's not that efficient. Like you're gonna have a lot of fluid left. And so the lymphatics are finger-like. They're slits that open only going inside, and they don't open. The liquid can't go back out. And so they are like vacuum, suction cleaner things that suck up the liquid around those tissues and help the capillaries pick up, the liquid gets picked up into the venous system. And then by the heart, both of those lymphatics and venous blood come together and the lymphatics gets dumped into the heart and the whole journey begins again for the blood. Lymphatics are interesting. I mean, that's also how, unfortunately, we clean the system. And so lymphatic nodes, lymph nodes, they're the ones that get inflamed when you get sick because there's a lot of white blood cells sitting there. Make sure your disease doesn't get into your infection, gets taken care of and all of that. So that's when we talk about the immune system. But the problem is the lymphatic system then also spreads the cancer. That's where we know a lot about the lymph nodes also. And so that's another part, unfortunately, that we end up mentioning when we talk about the lymphatic system. But really interesting stuff. So we have a little bit of questions on that in the blood vessel, but we're not going too far into the detail of these two chapters in this course. We're mostly doing heart in this chapter here. And then in terms of the pathology, I'm not having that open for you guys. I'm going to do that with you texting. But I do want you, and this is actually the only thing we do this week, we're reversing it a little bit. I'm asking you guys what kind of pathology would you like to do. I have been doing that. I'm getting a lot of good feedback. And I will now then reach out to others also. But please keep giving me ideas that you would like to do. And then I can pair you together in the back and make groups out of it. So you're not having to really do anything on that because the introduction here is just the choosing. And then I'll work it up and I'll post it at some point. Actually, you know what? No, I'm not going to post it yet. I want to take out the fact that you choose amongst themselves. We reverse that process this time and see how it goes. So with that, I think that's it as far as I'm concerned. We finished with the Padlet. I really appreciate you guys doing those because they help me understand how you guys are doing in the process. Okay, any questions?
No, I'm good. Thank you so much.
Good. Thank you, guys. Enjoy. Have a nice week.
Bye.
Thank you.
Bye.